Hi everyone, how are you? Today's topic is structure in C programming. Okay, first we'll see what is structure, how we how we are working with structure and why they introduce structure. Okay, so this we learn. So first one is what is structure. So structure is basically a user defined data types. Using structure we can define a data type which hold more than one element of different data types. How we have primitive data types like integer, float and character. See, previously we learned that array. In array we can we only store similar kind of data type, but in structure we only store we can store different types of data type. Like if you write integer x10, that means 10 elements you can store into this array. So name of the array is x and the maximum size of the array is 10. So 10 element can at a time you can store. But in and the value only it will accept integer type of value. Float value or character value it will not accept. But in structure you can store various type of values. Okay, so different kind of elements you can store. We have primitive data types like integer, float and character and double. Using structure we can develop user defined data types. Okay, so integer, float, character, these are the primitive data types. Okay, but here in structure we can create our own data type. Okay, so what user data type holds means that means it holds n number of elements. It holds more than one element of different data type. If you see the example, then you will give more clarity on that. See, so I am writing the example. See, the here I am writing the syntax and example of the structure. Okay, see, this is a syntax. Syntax is like struct, all should be in small, struct, and I'm writing emp. No, first I'm writing giving identity. There should be a gap between struct and identity. Okay, then opening and closing brace, two braces are there, opening brace and closing brace. That means structure is now this is the opening brace of the structure, and when compiler gets this, that means this is closing brace, that means ending of the structure. Okay, then within opening and closing brace you have to write some data type and variable like element 1. I'm copying the same thing. Two, 3. So first you have to write data type, then you have to write the name the variable. Okay, so here data type and element, and there should be a gap between data type and elements. Okay, after writing data type and a variable, you have to give the closing brace. Okay, after closing brace you have to put colon, that means ending of the structure. So it is mandatory. Remember one point, every structure ends with a semicolon, and see, every structure ends with a semicolon, and this is the keyword you have to give. Struct, that means compiler understand we are dealing with structure. Okay, then you have to write the identity. Identity means any name you can give. You can give your name also, like employee, student, car, mobile, any name you can give. Okay, there is no restriction. So along with the syntax, now we'll see the example. Okay, now I am writing the example. Example. Again I am writing struct emp, all should be in small letter. Then I am giving two braces, opening and closing brace. Within opening and closing brace I am declaring some variable like integer emp number, that means employee number. Then I am giving character e name and e name, this is a character. Then float e salary, employee salary I am writing. So all should be in small letter. Okay, so now this is our structure. Okay, so this is the name, this is the struct keyword, and name of the structure is employee. Name means identity, so you can understand that we are dealing with employee structure. So then you have to give the opening and closing brace. Then inside opening and closing brace you have to declare some variable. Okay, so you have to declare some variable, integer here, integer employee number, then character ename, because character ename is basically it will take maximum of 20 character. Okay, suppose your name is Rahul Chaudhary, so that means it will maximum, it will take 20 character. Okay, then float e salary. Okay, so our data type and variable is ready. Then I'm giving the closing brace. After closing brace I have to give colon, that means ending of the structure. Okay, so that means this is the ending of the structure. So our structure is ready. This is our structure. Structure is, previously I told you that structure is a, basically structure is a user defined data type. Okay, so structure is a collection of different data types. See, mm, in structure is a collection of different data types, like see, if I write array, so int arr 20, so I'm writing a array. So array is a only, it will accept integer type of element, it will not accept float or character type of element. So in array always we can store only one type of value at a time, we cannot store different kind of value. This is the main disadvantage of array. Okay, so here employee, here emp is the employee, is the identity of the structure. We can identify the structure with the help of this name emp. Okay, so emp is basically identity. Why they introduce concept of structure? Okay, why they, so our next question is, why they introduce concept of structure. See, so array versus structure, array versus structure. Okay, so using array we can store n number of elements. How many elements we can store? N number of elements we can store in array. N number of element we can store in array. Okay, like suppose here I am writing integer a 5, then equal to 5 comma 10 comma 15 comma 20 comma 25. So I am writing the I'm writing the elements. Okay, so I am declaring here int 5. So in memory it will look like that. See, 5. So here first element, this is called a0 position. This is called a1 position. All should be in small. A1 position. A2 position. A3 position. A4 position. This one. So 5 is a value, so 5 will go and store into that position. 10 will go and store into a1 position. 15 will go and store into a2 position. 20 will go and store into a3 position, and 25 will go and store a4 position. In this way all the elements will store. Okay, and each of the a0 has a different address, a1 has a different address, a2 has a different address, a3 and a4 all has different type of address. Okay, so in this way it will store into memory. So all the elements are in float, or see here all the elements are in integer. Okay, if I declare float, so it will only accept the float value, it will not accept integer, float, character. So we cannot store, we cannot do this into our array. Okay, so only homogeneous data elements we can store. Either all elements should be type integer or float or character. Always homogeneous element would be allowed to store using arrays. We cannot store like employee data, student data, some other any kind of different types of data we cannot store. When we want to more different types of data, at that situation we must go for structure. We cannot use array concept. Okay, so these are the very basic difference between array and structure. So these are the difference. So suppose in defining the structure, so see, so I'm just giving you a real life example of structure. See, next topic is, first you have to write increase the size so that you will understand. Struct emp. Again I am writing emp, creating a employee data structure. See, structure is very important, because when we learn data structure, everywhere you can see the structure concept is much more important in data structure. So you have to learn very well. Okay, integer, e number, in short, character, all should be in small, don't write any caps here, because if you write caps then it will show you the error. E name, giving 20. Okay, then float, e cell. Okay, so after completing my structure, so I have to give the colon, that means ending of the structure. Okay, so our structure is ready. So our structure contains integer, e number, integer is data type and e number is a variable, character, e name, character is a data type and e name is a array. Okay, so 20 elements it can store maximum of. Float, float, our salary is in float, so we write float e sal. Okay, so our data type is ready. This is our data type, so our data type is ready. So our data type is ready and structure is also ready. This is a structure is also ready, and this is our data type also ready. So structure contains different types of data types, so these are the different data types. But only array, in array you only can store integer type, or you can store character type, or you can store float type. One type of data you can store in array, but in structure, see, in structure different kind of data we can store. So that is very big difference. So just defining by the structure, it will get a memory allocation? Definitely not. When you are declaring that, that means that will not allocate any memory. Okay, suppose I am writing integer. If I write integer, is there any meaning of writing integer? No, because I'm just writing the data type. Okay, I'm not writing any variable. So if I write integer a, that means there should be a meaning of that. Okay, so if I write int a, that means integer is a data type and I'm declaring a variable a, and variable a only can store only integer type of value. See, here is a variable, and a variable can only store integer kind of value. So that is the meaning. If I write struct emp and if I write this data type, so there is the same meaning of if I write only integer, that is the same meaning. Okay, so this is actually a data type. Okay, this is a data type. So only data type is only one word. Data type, like primitive data type is only one word. Primitive data type, which are the primitive data type? Integer, float, character, double, etc., so on. These are the integer, these are the primitive data type. Okay, this is primitive data type. And structure is basically a user defined data types. So primitive data types are one word. See, integer is one word, float is one word, character, double, etc., all are one word. Okay, but if you write user defined data types is a two word. See, struct emp is a user defined data types, is a two word. Okay, so when you are not declaring structure variable, uh, it will not allocate any memory. Okay, so now my question is that how we allocate the memory to this one. How we need to create a variable. See, for example, okay, example, see the example. In main method, suppose in main method I'm writing void main. All of you know why I write void main. In main method I'm writing, okay, so inside void main, suppose I'm writing int. So if I write int, then there is only writing int, there is no proper meaning. If I write integer, okay, but if I write int, all should be in small, but if I write int a, if I write int a, that means it is a proper meaning. And how it is a statement, so this is called a statement. If I write int only, then this is not called a statement. If I write integer a, then this is a one type of statement. Okay, so in place of int we can have write struct emp. In, suppose, see, in place of int we can write struct emp. If you write struct emp, so there is no meaning. If you write the variable, so equivalent to struct emp and int, both are the both are like same, because both are the just data type. Okay, so here after writing a, so this will be a meaning. If you write struct emp, so there is no meaning. So if you write so in int is a data type. Okay, in place of int what we have write, we write struct emp. So we have to write, so combiningly this is a data type. Okay, this is the data type, very very important, because structure struct emp, this is a data type. Okay, struct emp is a data type, very very important. So primitive data type is a like a single word. Suppose integer, it's a primitive data type. Primitive data type is like a single word. Okay, like integer a. Okay, but user defined data type is a two word. This is called user defined data type. User defined data type is a two word. Okay, so this is basically data type, we understand. And suppose, so now I want to declare a variable, so I am writing e, then yes, there should be a proper meaning. If I write e, then it will allocate a memory space. Until or unless declaring variable, it will not allocate any memory space. Okay, so here integer is a data type and a is a variable. Here struct emp is a data type and e is a structure variable. Whenever we declare variable, how it's get memory allocation, So how memory bytes will be allocated? Okay, see, graphically I am showing you. I need a table. See, this position is called E number. This position is called E name. All should be in caps. E cell. Okay, in this way. So if you want to store any value, first it will store into E number position, then any character or any string if you want to store, then it will store in this position, and E salary will store into this position. Suppose I am storing employee number. Okay, like git slash 0369 is my employee number. Okay, so I can write employee name Rahul Chaudhary is employee name, and E salary is like 70,000 E salary. Okay, in this way we can store. So our job is to first declare a structure data type, and you have to declare a structure variable. Then it will actually allocate a memory space, then you can store the value directly. Okay, so structure variable always holds the base address. Okay, structure variable always holds the base address only by printing the base address. Okay, here E is called internal pointer variable. E is called a internal pointer variable because it is holding base address, that's why it is called a internal pointer variable. So how many bytes of memory will be allocated? So if I declare struct empe, then how many bytes of memory will be allocated? Can you see? Integer occupies how many bytes? 2 bytes. Okay, character will occupies 1 bytes, but maximum size is, see, maximum size is 20, so that it will take 1 cross 20, that means it will take maximum 20. And float, we write float, so it will take 4 bytes of memory. So total how many bytes of memory is required to store? 26 bytes of memory we need. Okay, so and see the suppose the address is like 2000 2046 is the address. Okay, so the address 2046 to 2047 it will take. Okay, and after that 2048, so e name will start from 2048 to 2048 to 20. Okay, 2067 memory. After that e salary will occupy, e salary will start from 2068 to rest. Okay, 2068 to 2072 in this way. So these are the memory. So how much memory we required? Total we need 26 bytes of memory. So how can we store the information and how can we retrieve the information? So this is basically what I told you, that this is the memory allocation. So now how can we store this information and how can we retrieve the information from the structure? So structure variable we can access with the help of accessor. Okay, accessor is a dot operator, so we can accessing very simple through dot operator. So dot, if you want to access the, if you want to access the value, then we need to use dot operator. Dot operator is look like that, dot, only dot. Okay, so see, suppose our variable name is e. So if I want to access the employee number, then I can write e dot e number. If I want to access the employee name, then I have to write e dot e name. Okay, if I want to access the salary, then e dot e salary I have to write. So e is basically a base address. Okay, and dot operator, and this is variable. Okay, e is basically base address, dot operator, and variable. Okay, so this is the introduction part of structure, define structure and declaration and accessing of structure. Okay, so how to find the size of the structure, how to find. So I can write a simple program to finding the structure. Okay, see, again I am writing the same program. I'm just copying from copy and paste. Okay, so our structure is ready. Now we are writing main method. Inside the main method I am declaring the variable for the structure. Okay, then I am writing main method void main. I am writing main method void main. Okay, inside main method I have to write inside main method I am declaring structure variable. First I have to give the struct keyword, then compiler understand that we are dealing with structure, then name of the structure. So compiler understand that the employee structure I am looking for. So then I am giving the variable. So variable name is like emp e1. E1 is a variable name. So this is basically data type and this is a variable. When you are writing e1, that means it will allocate a memory for the structure. Okay, so after writing this it will allocate a memory. Previously I showed you how the memory will be allocated. This memory will be allocated. So first of all it will blank memory, and so after that you can store the value into this memory. Okay, then I'm printing the size of the structure. Printf I am writing size is size size of employee, size of emp structure. So percent d, percent d comma, because the size of the total employee structure size, it will return the integer type of value, then that's why we give percent d. So I can simply call size of, size of is basically a function. Okay, so I am passing e. So e size, already we seen that size of the e variable is 26, so it will return 26. Printf. So another way I can do this thing, size emp is percent d comma size of, again I am using same function size of. Okay, so here, but here I am writing struct emp, I am just writing the data type. Okay, so it will return the full size. Okay, with the help of size of function, we are passing the variable of the structure or data type of the structure. Okay, so next thing is local structure and global structure. Okay, so next topic is our local structure and global structure. Local structure and global structure. What type of structure we should declare as a local structure? What type of structure we should declare as a global structure? Structure definition is common for all, it's called a global. Okay, structure definition is specific to a function, it is called a local. Okay, just like local variable and global variable, the structure definition inside a function is called a local structure. Outside the all function, it's called a global structure. So parallelly you will see, you will get more clarity on this. Okay, just I'm giving you example, local structure and global structure. Local means see, local means within the within a function the structure can be accessible, outside of that function the structure is no more. Okay, in but in global structure, so everybody can access. In if I write global structure, then everybody can access. So in from in every function you can access the structure, that is global structure. So in first I'm giving you a local structure, local. So local structure is like void main, all should be in caps. We are writing struct struct emp integer a, integer b. Okay, integer int is small, integer a and integer b, so our structure is ready. Okay, so inside void main I'm writing the structure. Okay, so along with the main function. Okay, then I'm writing, see, I'm writing struct emp e is allowed. empe or l, you can write l, that means local. Okay, local is allowed. Okay, because here see, void main is a function. Within main function I am writing a structure. Okay, and I am creating a variable for the structure, so that is allowed. Okay, but if suppose I have another function, that is check function. Okay, in check function, or you can give another function if you nc function. Okay, so if you write st, I will see it is struct emp l, not allowed, not allowed, because we are declaring as a local structure, local. Okay, see the local structure, so create I can create a variable for that structure within this main function. Outside of the main function, the structure no identity, so nobody know about the structure outside the main function. Suppose function is another method, so uh, function is another method, so we cannot access this structure from this function or this method. We cannot access, this is not allowed. Within a function we can access, but outside of the function we cannot access the structure. This is local structure. And see global structure. Global structure, global structure is like that. See, same program I'm just copying. Control V. Okay, but here doing one thing, cut. See, I declare the structure outside of the main function, so that means this is a global structure. So I can access this structure from anywhere. I can access the structure from main, I can access the structure from any other method or any other function. This is allowed because we declared this structure as a global structure. Global means everybody know the person. Okay, so a Bollywood actor, in everybody know the Bollywood actor, but in local actors or local drama actors, so everybody will don't know him personally. Okay, this is the difference between local and global. So global means everybody know, everybody understand, so I can access this structure. So you can write your structure inside main function, you can write your structure inside any another method or function, or you can write your structure outside of the main function. That means that will be a global structure. Okay, this is the concept of global structure. So global variables you can access anywhere in the application, no limitation. Local structure means defining a local structure inside a particular function, one you defined inside a particular function, that you can access only in the function. From outside of the function you cannot access. Okay, see, local structure outside of the main function we cannot access, it is not allowed. But in global structure, everywhere we can access, from everywhere. Okay, in from main also, from function also. Okay, so these are the difference between local and global structure. Okay, so these are the basic basic of structure. Okay, so next tutorial we will learn about how to initialize the structure directly and how to access them. Okay.